All right, guys, here is 9-1, day one. The first 8, you pretty much know how to do. I'm going to walk through a few of them just to refresh you because I know it's been a little while. So I'm going to do everything on here that is blank. The other ones are from the key, so you can log on Classroom, look at the key for the rest of it. So these are all explicit sequences. I'm sorry, explicit formulas for a sequence. So find the first 5 terms. First thing I'm going to do, since it's explicit, remember that's the elevator. I plug in 1 for the first term, 3 for the third term, 10 for the 10th term. So I just do this 5 times, right? I do A1 equals 6 minus -1 for the first, 6 minus -1 gets me 7, okay? 8-2, I do 6 minus -1 to the second. -1 to the second is +1, 6 minus 1 is 5. A3 for the third term, 6 minus -1 to the third. -1 to the third is -1. 6 minus -1 gives me 7. Five. Running out of room, but this is going to give me 7 as well. So 7 just oscillates between 7 and 5. Okay, this one's a little trickier just because there's fraction. I gotta watch out for parentheses, but not too bad. So for A1, actually, if it's a calculator type problem, you can plug in the function. So an equals 2 plus -1 to the x divided by x. You want to find the first 5 terms. This is an alternative way to do it. It's a lot quicker. Go to a table. That's going to give you all your terms here. So A1 is 1. It goes 1.5, 0.33. ¾ 1/5. So if you notice, the denominator is increasing by 1 because that's n. So on your first term it's 1, on your second term it's 2. The numerator is going between 1, 3, 1, 3, 1. So we can notice a pattern. That's neither arithmetic nor is it geometric. It's just a different type, showing a different pattern. I just put a pretzel in my mouth. I'm not sure why I did that, but you guys will figure it out. Okay, so for 5 through 8, find the number of terms from A7 to A27. Let's get to number 7. This implies that we have a sigma, and I start when x equals k plus 7, and I stop when it equals k plus 1. So over here, this would be like I had a sigma, right? And I started when x equals 7. I stopped when x equals 27. I guess I shouldn't have written that x equals, but it's your bottom and top index numbers. 7 and 8 are just tricky because there's variables involved, but it's no different. Like this could say just 1 and that could say 7. And then down here would be, I did this wrong actually. That's my, wow, that's my first mistake. Not that anyone's keeping track, but first one of the year. So x equals k plus 1, k plus 7. So I want to do my top number minus, in parentheses, my bottom number, and then I always add 1. This gets me k plus 7 minus k minus 1 plus 1. It's really messy. K's cancel out. I got 7 minus 1 plus 1 gets me 7 terms. Okay, number 8, same thing. I want to do from j minus 6 to j plus 3. So j plus 3 would be the top number. I do j plus 3 minus j minus 6. Then I add 1, always add 1. So I get j plus 3 minus j plus 6 plus 1. J's are out. And we get 10 terms. Okay, 9, 10, 11, right in summation, that's sigma notation. So remember, this right side here is always the right side of your explicit formula. So let's find the explicit formula. First term, second term, third term. It's alternating positive, negative. That tells me it's going to be probably geometric with a negative r value. So my first term times, let's see, this is times -2, it looks like, the n minus 1. So let's see, I need to know what term I'm starting with and what term I'm ending with. So I know I'm starting with the first term. I don't know what term number this is. Is it the 5th, 6th, 7th? I don't know. So let's use this explicit formula. This is the term value. This is the term number. So the term value is 2d6. Remember, these are tied together. I can't do that, but I can divide by 2. That gives me -128 equals -2 to the n minus 1. So I want to find -128 as a power of 2. Let's just try this real quick. -2 to the 6th. No, I think it'll be 7th, right? Yeah, because that would give me 128. So this is 2 to the -7th. I'm sorry. I'm really testing you guys today. That wasn't a mistake because I wasn't done. Okay, so this is -2 to the 7th equals -2 to the n minus 1. Well, n is going to equal 8. So that's my 8th term. So sigma notation is going to be start when n equals 1. I stop when it equals 8. And then the explicit formula, -2 times -2 to the n minus 1. Okay. 11 is one where it's not arithmetic, nor is it geometric. It's just something else. And that's what we're going to get into today and next class. So my first term is 3 to the 4th, right? That's n equals 1, n equals 2, n equals 3. So you might notice like, okay, well, it's always to the 4th power. So it's going to be an equals something to the 4th power. Was it n to the 4th? No, because then my first term would be 1 to the 4th. This would be 2 to the 4th. But it's always 2 more than n, right? On my first term, it was 2 more, which is 3 to the 4th. On my second term, n was 2. Well, my base was 2 more, it was 4. So this is actually going to be is n plus 2 to the 4th power. Okay, so we can probably tell, okay, well, if it's 15 to the 4th, that means this must be my 13th term because the base was always 2 more than the term number, so 13. So sigma notation, explicit formula, n plus 2 to the 4th power. Excuse me. Start when n equals 1, I stop when it equals 13. Okay, if you didn't want to do n plus 2 squared, we could say another way to do this, there's an infinite number of ways to do this. We could just say n to the 4th, but I don't want to start when n equals 1 because then it would be 1 to the 4th. Well, that's 3 to the 4th. So I would start when n equals 3 and I stop when n equals 15. So that's another way to do it. Not hugely important. You can do either one. They're both just as good. Okay, now let's talk about factorial notation. So factorial, you guys have probably seen this before, 5 with an exclamation point. We say 5 factorial. What that means is we start with 5 and we multiply by everything till we get down to 1. So 5 times 4 times 3 times 2 times 1. 12 factorial, we start at 12, we decrease till we get down to 1, we multiply all those together. Okay, so any number factorial, so n factorial, we start with n, and we subtract 1, subtract another 1, and this is going to continue, and I'm always going to stop when I get to 1. And then we're going to go into 0 or negative numbers. Okay, factorial button, just so you know on your calculator, hit the math, slide over to PRB, and it's option 4. Okay, so for example, 5 math ERB, option 4, 5 factorial is going to give me 120. Okay, so let me show you how we can do some simplification. 3 of these are worked out. 9 factorial over 7 factorial. If you were going to do this on a calculator, make sure you contain the bottom in parentheses. But what this means essentially is 9 times 8 times 7, and I continue this till I get down to 1. I guess you could stop at 2. The bottom's going to be 7, 6, 5, all the way to 1. And what's going to happen? Well, we know how to work with fractions, right? I have factors on the top and bottom. They're going to offset. And what am I left with? 9 times 8, 72. Let's see how this works when I have a variable involved. So n factorial is going to be n, and I decrease, right? So n minus 1, n minus 2. I don't know how many numbers there are, but I know eventually I'm going to get down to 3 times 2 times 1. Okay, my denominator, I start with n plus 1, and then I decrease by 1. Well, n plus 1 minus 1, that's n. Then I have n minus 1, n minus 2. I don't know how many terms are in the middle, but I know I'm stopping when I get down to 3 times 2 times 1 at the end. Okay, well, what's going to happen here? Look for these common factors. N cancels n minus 1, n minus 1. All of these will cancel with all of these. I'm not left with 0. I'm left with 1 on the top, and I'm left with n plus 1 on the bottom. So this is 1 over n plus 1. All right. So this one here, same thing. I start with 3n plus 1 on the top, then I decrease by 1, right? Then I go to 3n, then 3n minus 1, da 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 da. I continue till I get down to 3 times 2 times 1. Keep in mind, I don't know how many terms there are here because n's a variable. So this is 3n minus 1. Eventually, I get to 3 times 2 times 1. And same thing, 3n minus 1, these, and I'm left with 3n plus 1 on the top. All right, I'm definitely going to run out of time, so I think what I'm going to do is cut this, and I'll put a part 2. It'll probably be 7-8 minutes. Okay, so that does for part 1. Make sure you check the other one out as well, and log on to check out that document I posted that says start here. That's got the schedule for the week, and that'll have my office hours and also my I want to do a Zoom call during the class period. Not the whole class period, probably 45 minutes or so. When you log on to there, the office hours, they're both going to kind of act the same way. The office hours, I'll just be there and I'll answer any questions you have. The Zoom calls during class, I'm not going to go through the notes like I did here. That's what the video's for. But if you are like, wow, I don't understand how to do number 8 right here, you can log on to the Zoom call and just say, hey, Mr. Larson, can you show me number 8, and kind of go through that, and then I'll go through it for you. Okay. Guys, it's nice to be back. Best of luck with everything, and we'll talk soon.